Hello everyone. Today we are going to discuss about another exciting feature from JDK 21, that is pattern matching for switch. So let's see what this pattern matching for switch is all about. So coming to the utility of switches, we as Java developers have used switch cases and switch expressions and statements whenever we wanted to have different execution paths for depending on a condition or an object, or depending on the object's value. So this has enabled us to write very concise and very readable code. Now this pattern matching for switch enables us to provide patterns as the case labels, and also it gives us the ability to write execution path for null objects also. So for any object which is being passed in the switch case, so if it is null, we can now define what should be its execution path. The default behavior, as we all know, is that whenever you give by mistake or because of a bug or any missing check, if the switch case gets a null object, it throws null pointer exception. That is that's the case even today. But today we have the ability with this new feature, we have the ability to write execution path for null as well. And that is the second. And the third one is that now the safety of switch statements has been increased, because now let's suppose if we have uh, like we have written a pattern for a switch statement in a case. So now we need to, at the compile time only, we need to cover all the possible input values. So that is checked in the compile time itself. So that is a great utility, and it resolves or prevents the many bugs at compile time itself. So it may happen in that during the discussion for code, we will discuss that how in if else chain statement has the problem that where we can miss any condition, and that may cause a bug in the code. And existing switch expressions and statements continue to compile, so there is no problem, no change in that. So let's dive into the live code. Before seeing the live code demo, I would like to just bring into your attention that I already maintain a GitHub repository uh, for the account engineer Sunit, and under that the repo name is Java 21. So this repo contains the implementation code for the features which are there in Java 21. So the one which we are going to discuss today is pattern match switch.java, in which has all the use cases we are going to discuss for this feature. So let's dive into this code. So this is the my ID, and as you can see that I have done some special changes for the code demo. Here you can see that there is no class after the import statement. I don't have any package. Before that I don't have any package, and after that I don't have any class declaration, and also I don't have any PSVM, or that is public static void main method with a string array argument. So I am using the Java 21 preview feature called unnamed classes and instance main methods. For the full explanation and live code demo for this, you can watch another video of mine for this feature live code demo. So here I can, and also one more thing I have done is that I have to shorten the, like there is another future enhancement which is going to come maybe sometime later, that we need to write system.out.println all the time for printing anything. So for demos, obviously it is not for production code, but for debugging purposes at local, for the local debugging purposes, we always do that. So what I have done in order to shorten that lines for the demo, I have statically imported the out variable for the system, and then I have created one um, small utility method which does whenever I use this print, it will just say out.println, or it will do the printing for me. So here I am just using this main method to show you the code examples for the different switch statements and expressions we are going to write today. So now let's discuss the pain points. So prior to Java 21, we use chained if else with instance of operator for a use case where we have a object and we wanted to match the object with a particular type class. So here we have, let's suppose we want to format a string depending on the type of the object. So we used to write chained if else with instance of operator, and we used to format it according to it by mapping it to this class and this object. So the value of this object would be substituted to I if it is an instance of integer class. Similarly, we used to do it for other use cases here. So what are the pain points here is, one of all, it is not readable. So we are always repeating the same the operator instance of, and we are repeating the object object instance of all the time. And this if else chain statement, there's no guarantee that let's suppose if I remove this else if, so this code will compile fine. If I remove everything, if I remove all the else ifs, it'll I will and replace it with an else, it will also compile fine because it doesn't know at the runtime what will happen, and there's no guarantee from the compiler that there will be there's no execution path which is left unattended, or this code has not been written for that. So that is the utility of switch statement now in Java 21, that we will be the switch statement for a pattern case. We will be a pattern used as a case label. We that will at the compile time it will check if any input is missed for that pattern. So let's see how can we do that. So this is the Java 21 equivalent code for the above code. So this code, what it does is it will format the object and give a formatted string depending on the object type. So we have integer, we have long, we double and string, and it will formally, and at the end it will return the formatted string. In Java 21 case, you will see that the we are using a switch statement or a switch expression because it's returning a value, and then we are using case statements with just a simple pattern which this object should match. If this object matches this pattern, the value of this object will be substituted or to the this variable, and this variable can be used on the right side of the arrow. So this is a very concise and compact and very readable code. And one great feature is that let's suppose we we just comment. Let's suppose I am running this code now, and it's a preview feature. So let me, yeah. So in this one, if you see it prints Java string Java 21. That is for okay. I'm passing Java 21 on the top, and it is printing string Java 21 because Java 21 is a string type. It will go to this. Let me check what I have used. I have used format 21 value as integers max value. So it is printing integer, the max value for the integer here. And yeah, so here it is printing from this line number 53. And if I remove now, the switch case is going to check the fact that I am covering all the cases for the input. So let's suppose I remove the default. I comment out the default, and if I compile this one, so it will say the switch at line number 52 that the switch expression does not cover all possible input values. So the compiler is complaining that the switch expression is incomplete. So it checks at the compile time itself. And if I do the same here, if I let's suppose comment out everything, Let's suppose I comment out this else. I can just press enter and comment out this, and I will. So if I run this code now, if I compile, it compiles and it prints everything, because the if else leaves to the developer or to the person who is coding, to the fact that they should be covering all the cases here. So I'm reverting the change. Okay, and then so you can see the utility of this switch case, and it can be extended to many other use cases as well. Now let's go to the next use case, that is prior to Java 21, the switch statements and expressions throws null pointer exception if the selector expression evaluates to null. So if I pass generate response null as a when I'm using this method. So if I don't check check this statement that it is null and then return. If I proceed to this to switch statement, then what happens is it will throw a null pointer exception. So therefore, I can showcase this one. So if I run this now, I have used this generate response here, and I am passing null. So if I pass in null, so if I just remove this, if I comment out this check, and if I run this code, you will see null pointer exception cannot invoke string dot hash code because as this is null. So at line number 72. 72 is the switch statement start. So it is saying that null pointer exception is there. Now I have to always add this boilerplate code and check the null whenever I'm using switch. So if switch handle this statement as well, like where I have to deal with a null. So if it is null, I have to uh, take care of that, and then I have to also return from this, or I have to return from whatever the next, if the next statement is switch. So can we give the control to switch statement and expressions for dealing with null? Yes. So in Java 21, it allows a new null case label. So as you can see, that I can, for Java 21, if I give null string, so for the case label, I can also give a null value. So if I give a null value, I can take care of that by returning. Let's suppose I can return something, or I can do something about it rather than just I can deal with the null thing. So let's suppose I am passing in Java 21 response. I'm passing hello. So hello means it will come here, and it will say okay. So in this way, it will say see you, because hello or bye, it is saying see you. So in this case, I can pass null. I can deal with it. I can say I can use multiple string literals, and I can uh, deal with it, and I can also have a default string here. So if I go to the usage of this, and I can pass null here. So if I run this code again, so you will see that it is printing nothing to say. Means it is able to deal with the null case here as well. Now going to the next use case, that is pattern case labels can be applied to many values. So if you a case label can be applied to many values, and which leads to conditional code on the right hand side of the switch rule. So if you see the utility and the beauty of switch use case is that you have the execution path decision making in on the left side, and the execution of that whatever that path on the right side. and conditional, all the conditions which decide the execution path are always on the left side. So that is the beauty of switch statements and switch expressions. Now if we are having a use case like this, where the switch we are switching on a string, and then we are dealing with null, and then if it is not null, then we have to check whether it is yes or it is no, depending on the case, and we are deciding the execution path. So here the execution path also contains decision making, like we are deciding whether what to do, whether to print welcome or print goodbye, so or print retry. So what can we do about it? Can we improve this? Because we are giving the pattern case labels, so this is the pattern case label, but we are not able to simplify this further. So in Java 21, so this is Java 21 use case. To improve better, more upon it, so in we can now rewrite the above code using guards. So this is a very important and very special feature in Java 21, where can use guards. So we can now, it allows when when clauses in switch blocks to specify guards to pattern case labels. So instead of writing the or deciding the execution path on the right side of the expression, now what we can do, we can add when clause to the pattern case label, and then use the conditions here. So the case the to contrast, if I want to differentiate the string on the basis of its value, yes, no, because it is not a straight literal actually here. The use case here is that it can be capital Y and then small letter es. It can be capital YES, it can be small YES. So we want to use some method, some business logic here. So here what we can do is we can use when clause to specify guard to pattern case labels. So we can say when s equals, so this is already, if it matches string, so s will have the value. Then we can use s and say equals ignore case yes, and then on the right side we can write the logic. And similarly, we can add this type of when clauses to guard the pattern with case labels. So this way we can improve in Java 21. It is improving upon many use cases generally used by developers all around. And then, so this is a very important and key highlight of this feature, when clauses to specify guards. And the Java 21 version of another better, like to make things better. So when we apply all these features to our programming language, this will lead to a more readable style of switch programming. The complexity of the test appears on the left side, so that we are testing a condition that appears on the left side of the switch rule, and the logic that applies if the test is satisfied is on the right side of the switch. So this is the complete picture here, where what we are doing is we are returning a response depending on the value. Then the value passed to the switch. So if it is null, if it is string literal, so we can have multiple string literals satisfying a single rule. So y or small y. In case of a pattern case label, we can have guards when clauses, and then we can also have a. So here, if you see, and also it satisfies the rule. Now the check whether for a string, since if you see this is a string object, and can you see that all the cases correspond to all the possible input values. So it can be starting from null to string literals two conditions based upon some business logic or methods and APIs. Two, at the end, we are matching it to string, which is obviously will match if it does not satisfy any one of them. And there is no fall through here because it's a switch expression, so it does not have any fall through issue where after null it will go to y and then n and then and many more. So it will, if it does not match anything, it will say retry and it will just return the value here. So validate and input response. Let's see what we have written for this. So we are passing null and printing the value returned by it. So let's see if null, so it will say nothing to say here. So if I go to my already run code, so it will say nothing to say. Now next things are a bit sophisticated. So for that I have to just explain the given scenario. So this is the given scenario where we have a interface game classification, which is a sealed interface, and it permits only indoor game and outdoor game. It doesn't have any methods to uh, implement. And then there is a enum called indoor game, right? This indoor game, which implements game classification, obviously, and it has four enum constants: board, ball, video, and puzzle. And we have a final class outdoor. So enum obviously is final, and then we have a final class outdoor game. You can see the permits in the permits clause, and then implement game classification because it doesn't have anything to implement, because there's no implementation. To simplify this example, so prior to Java 21, the selector expression of the switch must be of enum type, which means that the label must be simple names of enum constants. So this is the enum, right? So this has four constants. So before Java 21, I had to I can just mention if I am passing indoor game, so I can just mention case, board, ball, video, and default. So it will fall through. It will print any one of them. Now what can we do better? So in this case, if you see, there are many ways of if you have this condition where the enum is implementing some interface, and then we can now the interface can be implemented in many ways, like with a final class, and then can be sealed, it can be a enum. So how can we use switch for the interface instance, like any instance which implements this interface? So that can be done in Java 21. So this code would be more readable if we could have a separate case for each enum constant rather than lots of guarded pattern. This code, if we can write now this code using the previous feature attributes, I showed you that I can, if I am passing a game classification here, so this can be used to match the pattern with guards. So this is not that much readable. Now I can first show you the code, and then the case indoor game S. So S, if it matches indoor game class, then it will substitute the value here. And the S, if it S is equal to the, since indoor game is enum, so if S is a board game, so it will print something. Similarly, we have a ball, and then we have video, and this is the case where it satisfies everything else. So there are four constants, so the fourth one will go and print puzzle. And for a case, so as I told you that we, for the switch case here, we have to have all the input, we have to have execution paths defined for all the cases of inputs. So for the last one is outdoor game, that is it is outdoor game, so it will print everything. Then now this is not readable because we are not able to use the enum constant directly, because it's a constant, right? It's an object of that class. It's a ready-made object created because of the enum feature. So we are not able to use it because it is a pattern matching, right? Pattern matching means it will say if it's of that class, and then it will substitute here. Here it is not, we are not able to do so, but in Java 21 it allows qualified names of enum constants to appear as a case constant. So what I mean to say is that maybe it's a bit confusing. Earlier, if you see before Java 21, we were using the case labels as simple names of Java enum constants. So these are enum constants, simple enum constants. We used to use like this. Now we can implement this feature this way with regards and say if you want to check if it's a board game, then you can say if it is indoor game and when and the indoor game is board, something like that. Or now in Java 21 it allows qualified names of enum constants to appear as case constants. Example indoor game.board. And it dropped the requirement that the selector expression be of any enum type when the name of one of that enum constant is used as case constant. Let me explain you this. So you saw this code before. Now see the simplified version of that here. So I'm passing the class as interface. So it can be of any class which implements this interface, and I'm passing an object of that type. So now I can just mention instead of saying pattern as indoor game and the value is equivalent to board, I can just mention the qualified name of the enum constant. So I'm using the qualified name of the enum constant. So it will now I will be able to match this case whenever it is of type board by directly using the qualified name. So in this case, I'm now able to use qualified name and I'm now able to use switch case over it. So I can just write like this. It is so easy. Board, ball, video, puzzle, and then outdoor game. So it can match the pattern. It can match directly without a pattern. If the obviously this is a enum, right? So enum, we have the value already. So this object directly we are able to match. So this is a very great feature for people who want to write readable code and they have hierarchy which has enums and classes which are from the same interface. Now the coming to the last feature highlight for this JEP is that we have now it is relaxed the requirement that the selector expression be of the enum type and we allow the case constants to use qualified names of enum constants. And so you can see the example here. So it is relaxed the requirement that the selector expression be of enum type and we allow case constants to use qualified names of enum constants. So you can see that I can use qualified name of enum constants as a label. This is what I highlighted here that we can now use this, right? So now we have this. So this is another example where I have interface currency which permits coin. Coin is a enum, and I can use this qualified names of enum constants here. And another one which I wanted to show directly in that web page only, that is here. So one more thing which you can see it here, I can show you. Yeah. So you saw this example which I took from the JEP page that as of 21 we can have qualified names. And another thing is that if you're using, you can mix the coin. So in this case, what happens is that we are passing the currency, which is the interface, and it is we are able to switch over the implementation enums and classes. So we are able to do with the enum constant, which is the implementation of this interface. In case of in another case where we are passing coin itself, so we are able to switch over the either the enum constant, the coin is a enum, so enum constant, or the qualified enum constant, enum value. So we are qualified. So if both can be evaluated to each other, then it is possible to do that. But in this case, if you say um, currency, that is the interface, and you can say coin heads is possible. Tails is not possible because it should be qualified. It is a type. It is a enum constant. Enum constant cannot be directly substituted with the currency. So that's the thing. We are able to do this. So I hope that you will be able to use this feature in your day-to-day coding, and it will really help you. And to just to summarize what we discussed today is that we first of all what we can do is we can instead of using a very cumbersome if else chained if else logic, and we can now move towards pattern matching for switch like this, and improve by adding null cases, and improve by adding when clauses. We can improve, so completely we can improve by adding null cases, adding when clauses as guard, and we can further improve by mixing and matching null, literals, guards, and also having a compiled compiler safety of checking that the input cases are all matched, all fulfilled by the switch expression. And also now we can have the facility for a case of enum. We can now, earlier we used to do enum constants. Now we are able to use guards, and even better, we can use qualified names of the enums to switch against a super class, a like interface, implemented interface. And another example we can see here, or we can, if you are using coin here instead of currency, you can either mix and match the heads, that's the enum constant, or qualified name of the enum constant together. So you can do both. This way you can utilize this. Thank you for watching this video.